Hello friends, this is Hasiba. Welcome to today's session on clipping algorithms. So far we have discussed about what do we mean by clipping, and also in the last session we saw two different types of transformation, that is window to viewport and window to a normalized square. Right. So in today's session we'll be discussing about what are the different types of clipping algorithms we have. So the topics covered in today's discussion are, in today's session are, we will be seeing a little bit about what do we mean by windowing concepts. We already know what is a window, right? But still we'll be seeing a little bit insight about what is windowing concept, a slight introduction on clipping. Then we'll be discussing about a brute force approach for clipping algorithm, and the most important and vastly used clipping algorithm is Cohen Sutherland line clipping algorithm, right? And the next topic, area clipping. Again we have one more Sutherland Hogman area clipping algorithm, right? So in today's class we'll discuss about line clipping. In the next session I'll be covering about area clipping algorithm. So as we know, what is a scene, right? So a scene is nothing but it is made up of a collection of objects which are specified in world coordinates, right? So these are our world coordinates, and this is a scene of a mountain, right? So when I have a scene, right, say for example I want to display only this particular part of the scene, right? So what do? I will clip it, right? So when we display a scene, I want only those objects within a particular window to be displayed, right? So the selection of the portion of the scene which we want to display is done by making use of window, right? That is why we say there are window coordinates, right? So which are called as xw min and xw max, and yw min and yw max, right? So these are our world coordinates, right? So we can also call them as a wx min, wx max, or wy min, wy max, right? So both are one and the same. We are discussing about the minimum of the world coordinates, x minimum, x maximum, and y minimum and y maximum, right? So this is called as a window. So now I don't want the entire picture to be displayed, right? I want only this part of the picture to be displayed. So I have selected it. Now what I will do is I'll be clipping it, right? So clipping means what? Selecting which portion of the picture you want to you want to display it on the display screen, right? Because drawing things to a display takes time, right? So if I want to draw the same thing, it will take more amount of time, right? So instead of that, I can just clip the part of the picture whichever I want to display, right? So I will be cutting this particular part of the picture and I will be displaying, right? So this is what we mean by clipping, right? So for the image below, right, say for example I have an image, right, which consists of lines and points. Now I have to select which ones I have to clip, right? So the ones which are inside the window, they have to be displayed, and the points which are outside my window, clipping window, should not be displayed, right? So this rectangular box what you are seeing, we call it as a clipping window, right? So the lines and points which are inside this clipping window will be displayed, and the point which is outside the clipping window should not be displayed, right? So in order to do that, we have different types of clipping algorithms, right? So the first algorithm what we'll be seeing is point clipping. That means we'll be selecting which particular point I want to display in my clipping window, right? Again, next type of clipping is line clipping, right? So here in this type of algorithm, we'll be selecting the line segments which we want to display. And then the third type of clipping, we have the fill area clipping. It is also called as polygon. It is basically used for polygons because polygon is a closed figure, right? So that is why they are called as fill area. Next we have the curve clipping, right? So you know what is a curve, right? So if you want to clip only a part of a curve, right, so then you will go for curve clipping algorithm, right? So then we have text clipping, right? Say for example you want to select only a particular text, right? So and you want to display it, then this particular thing is called as text clipping. Say for example in 2D clipping algorithms, I want to cut only algorithms and display on my display device, right? So that is called as text clipping. Like this we have 5 different types of clipping algorithms, right? So they are called as 2D clipping algorithms, right? So I repeat, they are point clipping, line clipping, fill area clipping, curve clipping, and text clipping, right? So let us see, in today's session we will be discussing about point clipping and line clipping algorithms. So coming to the first type of clipping algorithm, which is point clipping, right? So point clipping, it is very easy because here we are concentrating only about a point, right? So what is a point? It is nothing but x comma y. It has x coordinate and it has y coordinate, right? And when it is not clipped, it is not clipped if it is outside the window, right? So what do I mean by that is, say for example, consider this figure, right? So inside this figure, this is my clipping window. If a point P5, if it is within the window, right? So within the window means it is not clipped, not clipped in the sense it is not cut, right? So it will be displayed as it is, right? So P5 will be displayed as it is, P1 point will be displayed, P3 point will be displayed, right? Whereas P10 point will be clipped, that means it is cut, right? P2 point is also cut, right? And P4 point is also cut, P7 point is also cut, right? So only those points which are inside my window, only those points will be displayed and they are not cut, right? So that is what it means. If at all I have my x point which is inside wx min to wx max, that is wx min is less than or equal to x is less than or equal to wx max, or if I take wy min is less than or equal to x is the less than or equal to y is less than or equal to wy max. That means if any point, any x comma y point, if it is inside this window, right, then that particular point, then that particular point will be that particular point you can see, right? It is not clipped, right? So it is not cut. That is what it means. Clip means cut. It is not cut, right? So if at all, if a point, if it is outside the window, then we will be clipping that particular point, right? So this type of algorithm, we call it, this type of clipping, we call it as point clipping. The next type of clipping is line clipping. What do we mean by line clipping, right? So line clipping is nothing but clipping a particular line, right? So this line clipping is little bit harder, right? So why we say it is harder? Because say for example in the first case, right, so we have to check here whether the endpoints of each line are inside the window or they are outside the window, right, or they are halfway, right? So what do we mean by that? First one is, say for example, both the endpoints are inside the window, right? That means the line is completely inside my window. That means don't clip, that means don't cut that line, that entire line should be displayed, right? So the second case is one endpoint is inside the window whereas other endpoint is outside the window, right? So you can see that a line segment means it will have two endpoints, right? So in this case both the endpoints are inside my window, right? So since they are inside the clipping window, they are not clipped, they are not cut, the complete line will be displayed, right? But if at all I have one point inside the clipping window and the other is outside the clipping window, at that time what I have to do, I have to clip, right? So I have to clip and I have to display only those points which are inside the clipping window, right? Now for, say for example, if both the endpoints are outside the window, if both the endpoints are outside the window, say this line, this is completely exterior to the window, so this point will not be displayed, right? So if I take this particular line, so it's two endpoints, this point 1 and point 2 both are outside the window, but little part of the line is inside the window, right? So what I have to do, I have to cut, not in such a way, I have to find the intersecting points and I have to cut it in such a way that only this particular line which is within the window should be displayed, right? The same thing for here also, only this particular part of the line within the window should be displayed, right? So in order to do these jobs, we'll be making use of our line clipping algorithms, right? So the first simple approach, right? So before inventing Cohen Sutherland line clipping algorithm, right? So they invented brute force line clipping algorithm. In brute force line clipping algorithm, it is very simple, right? So it tells don't clip lines with both the endpoints within the window, right? That means if the line is completely inside the window, then you should not clip it, right? Don't clip the line if both the endpoints are inside the window. If both the endpoints are inside the window, then don't clip that particular line. For the lines with one endpoint inside the window and one endpoint outside the window, if at all I have a line where one endpoint is inside the window and one endpoint is outside the window, then what we have to do, we have to calculate the intersection point using the line equation, right? So we know the line equation is y is equal to mx plus c, right? So that is our slope intercept equation, right? So using that particular equation of the line, what we have to do, we have to find the intersection point. That means where it is intersecting my window, right? So from this particular point till the point of intersection, it should be displayed and the rest part should not be displayed. right? So continuing this, for lines with both the endpoints outside the window, right? So if the line is completely outside the window, right, outside the window, then test the line of intersection with all of the window boundaries and clip appropriately, right? So both the endpoints are outside the window, then what we have to do? If both the endpoints are completely outside the window, then it is exterior, right? So that will not be displayed. It will not be displayed. If at all I have both the endpoints outside the window and again there is an intersection, means what I have to do? I have to find the intersection properly and then I have to clip it properly, right? But calculating this line intersection is expensive. Calculating intersections every time is actually expensive because a scene may contain so many lines. So the brute force approach to clipping is very much slower, right? It is too much slow. So in order to overcome this disadvantage, right, so we have invented one more algorithm which is called as Cohen-Sutherland line clipping algorithm, right? So you can see here before clipping and after clipping, right? So many lines are there here. P1 to P2 is one line, P3 to P4 is one line, P5 to P6 is one line, P7 to P8, again P9 to P10. So many lines are there, right? So the one which is completely inside the clipping window, P1, P2, will be displayed, right? So P9 to P10 is exterior to the clipping window, sorry, exterior, that means outside the window, so it is not displayed. P3, P4 is again completely outside the window, it is not displayed, right? So here I have P7 to P8, right? So in this line both the endpoints are outside the window, but it is still intersecting with my clipping window. That is why I will find the intersection points as P7 dash and P8 dash, right? And this part of the line which is inside my clipping window will be displayed, right? So coming to this P5 and P6, here one point is inside the window, one point is outside the window. So what you have to do? You have to find the intersection point of this particular point, right? So that is P5 dash, right? So P5 dash will be the intersection point. So now P5 dash and P6 will be displayed, right? So like this line clipping algorithms will work. So moving to our Cohen-Sutherland line clipping algorithm, right? So it is an, as the name suggests, Cohen-Sutherland, right? So these were the two scientists who invented the Cohen-Sutherland line clipping algorithm. It is an efficient line clipping algorithm, right? So because the main advantage is it reduces the number of line intersections that must be calculated, right? So the number of line intersections, here also we'll be calculating the intersections only, right? But the number of line intersection which has to be calculated is reduced compared to brute force approach. That is why this Cohen-Sutherland line clipping algorithm is vastly used. So one of the earliest algorithm for fast line clipping is Cohen-Sutherland, right? So because processing time is reduced by performing more tests before proceeding to the intersection calculation. Simply directly, we don't go for calculating the intersection. Instead we do some calculation, right? So we do some tests and then we check whether we have to calculate the intersection or we should not calculate the intersection, right? That check we do here. But in brute force approach, simply we'll be calculating the intersection coordinates, right? But in Cohen-Sutherland algorithm, before calculating any intersection point, we have few conditions. Based on that conditions, if it is required, we'll go for finding the intersection point, otherwise no. Right? So that is the advantage of Cohen-Sutherland line clipping algorithm. In Cohen-Sutherland line clipping algorithm, every line endpoint is in a picture is assigned a 4-bit binary value. That means if I take any point, right? So it can be a point P5, right, or P8, anything, any endpoint in the line, we is assigned some 4-bit binary value like this: bit 1, bit 2, bit 3, bit 4, right? It is a 4-bit binary number, right? So this particular binary value, we call it as the region code. It is called as the region code, right? So each bit position, it is used to indicate whether the point is inside the clipping window or it is outside on one of the clipping window boundaries. That means, say for example, if I take this as my clipping window, right? So P6 is inside the clipping window, P2 is inside the clipping window, P1 is inside the clipping window. But what about P5? P5 is towards the left of the clipping window. P8 is towards the right of the clipping window. P7 is towards the bottom of the clipping window. P9 is towards the top of the clipping window. The same way P3 and P4 are towards the left of the clipping window. P10 is towards the right of the clipping window. Like this, every point will be identified by a 4-digit binary number, depending on where it is situated, right? So in order to identify them, what we have is we have 4 bits: bit 1, bit 2, bit 3, bit 4. Because every clipping window will have what? It will have left, right, top and bottom. It has left, right, top and bottom. That is why we have 4 bits, right? So bit 1 is set to 1. Bit 1, I will make it as 1 if my point lies to the left of the window, right? So if the point is towards the left of the window, bit 1 is made as 1. Bit 2 will be set to 1 if the point is towards the right of the window. Bit 2 is set to 1 if the point is towards the right of the window. Bit 3 is set to 1 if the point is below the window. Bit 3 is set to 1 if the point is below the window. Bit 4 is set to 1 when the point is above the window, right? So if you take this window, bit 1 will be set to 1 if the point is towards the left of the window. Bit 2 will be set to 1 if the point is towards the right of the window, right? So bit 3 will be set to 1 if the point is below the window. Bit 4 will be set to 1 if the point is above the window. That is what is left, right, bottom, top, right? So you have to remember here, right? Or it is called as ABRL rule, right? So above, below, right, left, right? Or you can call it as a TBRL rule, right? So the bit values in the region code are determined by comparing the coordinate values x comma y endpoints to the clipping boundaries, right? So how we are identifying them, right? Say for example, need to identify these points, right? So look at here in this. Look at this, the algorithm, what it will do, it will divide the two-dimensional shape into 9 regions. So this is above, below, right and left, right? So left of the clipping window means bit 1 is set to 1. Right of the clipping window means bit 2. This is nothing but your bit 1, bit 2, bit 3 and bit 4, right? So left of the clipping window, bit 1 is set to 1. Right of the clipping window, bit 2 is set to 1. Below means bit 3 will be set to 1. Above means bit 4 will be set to 1. Like this, inside the clipping window, it is always, the region code is always 0000, right? So like this, first we will identify all the region codes, right? So now I have to give the region code for a point which is here, right? So where it is there, it is below and it is towards the left, right? So since it is below and left, right? So see here, left means it should be 1, bottom or below means it should be 1 in the bit 3, right? So combining these two, I will get it as 0101 because it is towards the left and it is towards the bottom. So coming to this point is towards the left and it is above the clipping window, right? So since it is towards the left, so bit 1 will be 1, and since it is above, right, bit 4 is 1, right? So combine these two codes and you can write the code for this particular region, right? So coming to this region is towards the right and it is above, right? So right and above, right means bit 2 is 1, above means bit 4 is 1, right? So combining these two, right, it is literally adding these two, right? So 1010 is what you get, right? So then in order to write this particular region code, what we do is we consider this is towards the right side and it is bottom, right and bottom, right? So combine these two, right and bottom, you will get it as 0110, right? So like this, we will divide the two-dimensional space into 9 regions, right? So 1 2 3 4 5 6 7 8 9. So hope it is clear, right? So this code is also called as ABRL code, right? So first we will define that is what is explained here. Bit 1 is set to 1 if x is less than xw minimum, right? If it is set to 1 if x is greater than xw maximum. That means if it is towards the left, it is x is less than xw min. Yes or no? This is your xw min, yw min point. Always lower left corner and upper right corner is xw max comma yw max, right? So if x value is less than xw min, yw min means then bit 1 is set to 1. If x is greater than xw max and xw max means bit 2 is set to 1, right? So the same thing holds good for bit 3, right? So bit 3, it is set to 1 if y is less than yw minimum. It is set to 1. Bit 4 is set to 1 if y is greater than yw max, right? So the same thing is explained here, right? So then what we have to do, use the resultant sign bit. We are calculating the region code. This is not required, right? So if it is clear with this point, just remember bit 1 will be set to 1 if it's left side, bit 2 will be set to 1 if it is right side, bit 3 will be set to 1 if it is bottom, bit 4 will be set to 1 if it is above, right? And if you want to write the region code for all this, it is just combining, it is left bottom. So left bottom, combine and add and write here, right? So it is left to top, so left top, add and write here. This one will be right top, so right top, add and write here. This region code will be right bottom, so add and write here. That's all, right? So next, for any given line, Cohen Sutherland algorithm is very simple, right? So we will be considering three cases here. The first case is for any given line, it has two endpoints, right? So the endpoints are P1 and P2. If both the endpoints have region code as 0000, right? So if both the endpoints have region code as 0000 means what? The 2 points are inside the clipping window. That means it will be like this. P1 is a point and P2 is a point. If both the endpoints, they have the region code as 0000 because they are inside the clipping window. So if both the endpoints have the region code as 0000, right, then they are completely inside. That means they are interior. So that particular line will be visible, right? So that is the first case. Case 1 tells that if both the endpoints of the line have the region code as 0000, then that particular line is completely interior, right? So we can make it as visible, right? So the second case is if both the endpoints have a region code value of 1, right, in at least one one same bit position, right, then it is completely outside the clipping rectangle and we eliminate that line segment, right? So what do we mean by this line is, in short, I have written here, if at all say P1 is a point and P2 is a point, right, and they both are non-zero. Non-zero means they are not inside the window, right? So they are outside, because you can see that if it is inside the window, then only it is completely zero, right? So any point if I take outside, right, so it is always non-zero, right? So if the line is present, say for example line is here, if the line is present and both the endpoints have a region code which is non-zero, and you will perform a logical AND operation, right? So you know what is logical AND. If it is 00, it is 0. 0 and 0 is 0, 1 and 0 is 0, 0 and 1 is also 0, 1 and 1 is 1, right? Say for example, I will consider a line in this particular region. What is the region code here for point 1? 0, 1, 0, 1. What is the region code for again point 1, point 2? Again it is also 0, 1, 0, 1. Or else if you consider a line which is like this, say for example, one point is here, one point is here, right? So the region code for the first point will be this, the region code for the second point will be this. You have to perform logical AND operation here. 1 and 1, you will get it as 1. 0 and 0, you will get it as 0. 0 and 1 is 0. 0 and 0 is 0. So you will get it as 0, 0, 0, 1. Right? So if you perform the logical AND operation and the resultant of the logical AND operation is also non-zero, right? So we got it as non-zero. That means that particular line is exterior, right? So if it is exterior, it is invisible, right? That means it is outside my clipping window. So that particular line will be invisible. This is the second case. Hope it is clear, right? So first we'll check P1 and P2. If they are both the points have the region code as 0000, that means it is interior and the line is completely visible. If I take the points P1 and P2, which are both are non-zero. Non-zero means they are lying outside the clipping window, right? We perform the logical AND operation of their region codes. Logical AND operation is performed for their region codes. After performing the logical AND operation, if the resultant of the logical AND operation is also non-zero, if it is also non-zero, then I say that that particular line is exterior or else it is invisible, right? Exterior means it is invisible, right? So if at all there is one more case, if the lines that cannot be identified as completely inside or completely outside, they are checked for intersection, right? So whatever case we discussed here, this case is for the line which is completely interior, and this is for the case which is the line where the line is completely exterior, right? But what if we have a line which is partially inside and partially outside, right? So at that time we have to go for intersection, right? So as each clipping window edge is processed, a section of the line is clipped and the remaining part of the line is checked against the other window borders. That means we'll be finding the intersection of that particular line, right? So look at here. If at all I have this case, what I will do, I will be finding the intersection point, right? So the intersection point with respect to the window borders, right? So P7 has an intersection point which is P7 dash, right? And P8 point has an intersection with this window border which is P8 dash, right? So we'll be finding the intersection points P7 dash and P8 dash, right? So the same way here, that is what is written here. As each clipping window edge is processed, a section of the line is clipped and the remaining part is checked against the other window borders. Then what we do, eliminate the section until either the line is totally clipped or the remaining part of the line is inside the clipping window, right? So you have to eliminate those part of the lines which are outside, right? So for example here, we were eliminating from P7 to till here we are making it as invisible, and P8 to till here we are making it as invisible. So what is visible? Only this part of the line which is inside the clipping window will be visible, right? So that is what is the third case. This is the third case, right? So in short, I write it as, say for example, one of P1 and P2 is 0. There are two cases here, right? Either one point of the one region code of any one of the point, a region code of any one of the point is 0, right? Or both the region codes are non-zero, right? But the logical AND is 0. One of the region code is 0 and the other is non-zero. What do we mean by that? One of the region code is 0. Say for example, I have a line where it is like this, right? One of the region code is 0, because P6 you can see it is completely inside the clipping window, whereas P5 has the region code as it is towards the left, right? It is non-zero, right? So I can have one case like that where one of the region code is, one of the point is 0 and the other point is non-zero. Sorry, one of the point is any one of the point is 0 and the other point is non-zero. Or I can also have where both are non-zero, but the logical AND I will get it as 0. Both are non-zero, logical AND is 0, right? Means that this line P7 and P8, right? So both are non-zero, they are outside the clipping window. The region code here is also non-zero, region code here is also non-zero, right? But when I do logical AND operation, I'm getting the resultant as 0. At that time I have to go for finding the intersection point. Then I have to find the intersection point, right? So in order to find the intersection point, right? So what we do, we make use of the slope intercept form of the line equation, right? So we know what is the slope intercept form of the line equation. Y is equal to mx plus c, right? And we know what is the slope. Slope is calculated by using y2 minus y1 divided by x2 minus x1, right? So for a line with endpoint coordinates as x0, y0 and x and y end, right? So what will be the slope? Slope will be equal to y end minus y0 divided by x end minus x0, right? So for in this particular equation, we have to solve for y. Y is nothing but our point, right? So y will be equal to y0 plus m into, so just solve this equation. M is equal to y end minus y0, right? So y end is nothing but your y here, right? Y minus y0 divided by x minus x0. Take m is equal to y minus y0 divided by x minus x0. If you take like that, you will get it as m into x minus x0 is equal to y minus y0. So y will be equal to y0 plus m into x minus x0, right? So take x and y end as your x and y, then you will be able to find out the y, right? So for intersection point with a vertical clipping border line, y coordinate is obtained with the calculation, right? So we will be calculating the y where x value is set to either xw min or xw max. That means I'm considering the line which is vertical clipping, right? So I'm doing the clipping like this, right? Say for example, I'm clipping this part, right? So vertical clipping line border. At that time, I will be taking my xw min. Xw min will be my x value, right? So we'll come to that. Xw min, or we can take it as xw max, right? So this you will understand while we discuss the problems, like how we consider xw min or xw max, right? So hope you have understood how we got this y, right? Just substitute y and x and as just simple y and x, right? So at that time what will happen? M is equal to y minus y0 divided by x minus x0. So m into x minus x0 is equal to y minus y0 you will get, right? So if you take this minus y0 this side, you will get it as y is equal to y0 plus m into x minus x0, right? So like this you will be calculating your y value. The same way we can also calculate the x coordinate, right? So for intersection with horizontal border, right? So we have to calculate the x coordinate, right? So horizontal border in the sense this part, this is called as horizontal borders, right? So the upper part and the below part we call it as horizontal border, this we call it as the vertical border. For intersection with vertical border, I'll be calculating y. For intersection with horizontal border, I'll be calculating x, right? So calculate x. So how do you calculate x, right? So we know that m is equal to y minus y1 by x minus x1, right? Or x minus x0, y minus y0 by x minus x0, right? So m into x minus x1 will be equal, x minus x0 will be equal to y minus y0, right? So x minus x1 will be equal to y minus y1 divided by m. So x will be equal to x1 plus y minus y0 by m. That is what we are doing, right? So x will be equal to x0 plus, right? So take your x1 y1 as x0 and y0, you will get m is equal to y minus y naught divided by x minus x naught. So m into x minus x naught will be equal to y minus y naught. So x minus x naught is equal to y minus y naught divided by m. So x will be equal to x1 plus x naught plus y minus y naught by m. X is equal to x naught plus y minus y naught by m, right? So like this, you will be calculating your x coordinates and y coordinates. Okay, so this y will be y min for bottom boundary, it will be y max for upper boundary, right? So this you will understand while we take up the problems, right? So let us solve one simple problem for Cohen Sutherland line clipping algorithm, right? So it is very simple and very easy and repeatedly asked exam question. Explain Cohen Sutherland line algorithm, and you have to, at that time you have to write all the three cases, right? So all the three cases what we have discussed here, I repeat, first we will check whether the 2 points are having the 0 0 as the region code, that means they are completely interior, it is visible. Then we'll check whether those 2 points both are having non-zero but the logical and is also non-zero, that means they are completely exterior, right? But if I have that one point is region code, one point is inside and the other point is as a 0, right? At that time I have to go for intersection, or else both are outside but logical and is a 0, both are outside but logical and is 0, again I have to calculate the intersecting point. So we are calculating intersecting point only for these two cases, right? So coming to the problem, so the problem says use Cohen-Sutherland algorithm to clip the line, right? So with two endpoints, P1 is 40, 15, right? So this is the line P1 which is 40, 15, and P2 is what, 75, 45 against the lower left hand corner. Lower left hand corner means XW min and YW min, right? So lower left hand corner is 50, 10, and upper right hand corner, that is XW max and YW max, upper right hand corner is 80, 40, right? So we have to make use of the Cohen-Sutherland line algorithm and we have to find out the intersecting points. That means here one intersecting point we will get, right? What is the formulas we got? We got the formula as y is equal to y naught plus m into x minus x naught, right? So here we have written it as y1. You can write anything. Y is equal to y1 plus m into x minus x1, and what is x? X is equal to x1 plus 1 divided by m into y minus y1, right? So this entire problem can be solved by making use of only these two simple equations, right? So this is how your clipping window looks like, right? So lower left corner means it is they are referring to this particular point, that is the point what we have taken as 50, 10. This is our XW min and YW min. Upper right hand corner means this is the point which is 80, 40, which is XW max and YW max. Okay, so now coming to the point, right? So what is the point? The point is 40, 15 and 75, 45. Right? So if you see the point P1, where it is located towards the left hand side of the clipping window. So if it is towards the left of the clipping window, then which bit I have to set to 1? I have to set bit 1 as 1, right? So my region code will be 0 0 0 1. This is the region code, right? So coming to point 2, this point is situated above the clipping window. If it is above the clipping window, then bit 4 should be set to 1, right? So I will come here, I will set my bit 4 as 1. I will get 1 0 0 0. Now what I have to do is I will see both are non-zero. If both are non-zero, I have to check the logical AND, right? So when I do logical AND, 1 and 0 0, 0 and 0 0, 0 and 0 0, 0 and 1 is 0, right? So when I do logical AND, it is 0, right? So then I have to go for finding the intersecting point, which is x, y, right? So here I have to find how many intersecting points? I have to find 2 intersecting points, right? So one intersecting points along the vertical border, other intersecting point along the horizontal border. Right? So let us start by finding the intersecting point along the vertical border, right? So hope it is clear for you. What we are doing, we are checking the region codes for the point where they are located. We are writing the region codes and performing the logical AND operation, right? So if the result of my logical AND is 0, then I have to calculate the intersecting points, right? So intersecting point is x, y. So now coming to the problem, what is my XW min? XW min is 50. XW max is 80. What is my YW min? It is 10. What is my YW max? It is 40, right? So first I will note down the values given. What is the formula to calculate the Y point? Y is equal to, right? So if I take this particular point, I have my x which is located on what? It is located on xw min, right? So x will be 50. What I have to find? I have to find y, right? So to find y, the formula is y is equal to y1 plus m into x minus x1, right? So this particular point, P1 point, we have to consider as x1 comma y1. This is the formula, right? So we have to find the slope here. What is m? M is equal to y2 minus y1 by x2 minus x1, right? So we know that the points are 72, 45 and 45, 40 comma 15. So this is x1 y1, x2 y2, right? So y2 minus y1. So for 45 minus 15 divided by 75 minus 40, if you do, you will get the value for your slope, right? So find that slope value, which is m. Now what is my point? This point I will take it as x1 comma y1, because I have to find the intersecting point x comma y here, right? So this will be my x1 comma y1. So what is the y1 value? Y1 value is 15. 15 plus the slope value, which is m value, into x. What is the x value I have? I have x value, right? So x value is coinciding with what? It is coinciding with my xw min, right? So xw min is 50, so x value will be 50. 50 minus what is my x1? X1 is 40, right? So if you solve this, you will get the value of y as 23.563, right? So my first intersecting point is x comma y is equal to 50, right? So because it is coinciding with my vertical border, x will be same, right? So x will be 50 comma y value, what I got, 23.563, right? So I will mark this point as 50 comma 23.563, right? So now I have to calculate what? I have to find one more intersecting edge. So what I will do to find this particular intersecting edge, right? So we know that this is coinciding with the horizontal border. Horizontal border means I have to find the value of x, right? Because my y value will be same. Y value will be this value, which is my y max value, which is 40, right? So yw max value, which is 40 here. So y will be constant, only x value I have to find. So x formula is x is equal to x1 plus 1 divided by m into y minus y1, right? So 1 divided by m is the same slope, right? So what is your x1 y1 here? X1 y1 is your point 75 comma 45, because you are finding the intersecting point with respect to the point P2 here, right? So point P2 is 75 comma 45, right? So 75 will be your x1 plus 1 by m into what is your y value? Y value is 40, because it is on the vertical, because it is on the yw max, right? So that is why 40 minus what is y1 value? It is 45, right? So substitute that and solve, you will get the value as 69.2. Right? So this intersecting point will be what? It will be 69.2 as your x value and 40 is your y value, right? So like this, you will be finding your intersecting points, and you will say that which particular part you will make it as visible. 50 comma 23.563 to 69.2 comma 40, right? So this particular part we will make it as visible, and the remaining part, this part from 69.2 to 75 part, it is invisible because it is outside the window, and from 40 to 50 comma 23.563, this particular part is also made as invisible. That means this, from this entire line segment, only this particular part which is coinciding with my clipping window will be visible, right? The other two parts will be cut, right? So like this, we have to find the intersecting points. So the line between these two intersecting points will be visible now. So now this point will be my P1 dash, and this point will be my P2 dash. So P1 dash to P2 dash will be visible. This is how we solve the problems on Cohen-Sutherland line clipping algorithms. Hope it is clear, right? So if you have any doubts, you can just ask me. Try to solve this problem, right, by taking any other endpoints and by taking your xw min, yw min and xw max and yw max as some values, right? So assume some random values and try to solve the problem. Concept is very simple, right? It has only 3 cases here, right? So the first case, both are interior. Second case, both are exterior. The third case, one is interior, one is exterior. What we have to do, right? So these are the 3 cases. We have to find the intersecting edges like this, right? Thank you.